Good morning and welcome once again. So, till the last lecture, we have seen some of the basics of image processing, and now today we are continuing with this same, that is the simple image formation model. So, as we have discussed already, that the monochromatic image, that is a two-dimensional function, it is in a mathematical view, the monochromatic image is a two-dimensional function f of x comma y. We have already seen this. What is f of x comma y? It is the function to represent a two-dimensional image where x comma y are the spatial coordinates and f is the amplitude, or you can say it is the intensity or the grayscale value at x comma y. We have already discussed it. Now, they have the span, the values of the monochromatic image or the intensity, they have a span that is called as the grayscale. How it is, that span is, it is ranging from 0 to the maximum grayscale that is allowed depending on the k bits that we have already discussed. And what is x comma y and the amplitude value? They all are finite discrete quantities, and as we are discussing in the digital image. Okay, so they all are the finite and the discrete quantities. So the function, you can say, as it is a non-zero and finite, you can call the same function as 0 is less than f of x comma y is less than infinity. This particular term represents that it is a, this particular term represents that it is non-zero as well as it is a finite function. Then this function, we are considering it is the product of two components. Which two components? We have seen that we have to capture the image in the presence of light only. So the light, amount of light which is illuminated on the object, we call it as an incident on the scene, and it is indicated using I of x comma y. And the amount of illumination or the light reflected by the object from the scene, we call it as R of x comma y. If you know the simple theory, the color of any particular object depends on what color it reflects more. For example, if green leaves, then the leaves are reflecting green color more, and that's why you can see the object as a green color. So both things are important: how much light is incident or the illumination is incident, and how much illumination is reflected. If it is a total light incident on the object, we call, that means total light is absorbed by the object totally, then we call it as zero, a total absorption, whole black color. And if it totally reflected by the object, it is, we call it as a full reflection and indicated with 1. Many times it is termed as white color. So two color ranges in any grayscale: total black and total white, and all the colors in between, all the grayscales in between. And what are the two extremes? Total black and total white. Total black indicates full color is absorbed or full illumination is absorbed, and white color indicates full color, full light is reflected. Total reflection 1, total absorption 0. And that's why this particular function f of x comma y, as we are telling, it is a product of these two terms, I of x comma y into R of x comma y, where I of x comma y, as we have already seen, it is a finite non-zero, and that's why 0 is less than I x comma y is less than infinity. And we have seen R is in between these two, total absorption and total reflection. That's why it is 0 less than R x comma y less than 1. Okay. Note that this equation indicates the reflectance bounded by, as I told you, total absorption by 0 and total reflectance. So these are the two limits, two boundaries of this function: total absorption and total reflectance. The nature of I x comma y is determined by the illumination source, and R x comma y is determined by the characteristics of the imaging object. So what kind of object it is, depending on that, there is a reflection and illumination is determined. Okay, so if it is a very flashy object, so that time it reflects more. If it is a darker object, with not very good surface area, it will absorb more. Then as we continue with the simple image formation model, and we have already decided two functions, I of x comma y, r of x comma y, and f of x comma y, it is nothing but it is the product of these two, I of x comma y and r of x comma y. Now, as we have discussed, they are the intensities of the monochrome images. And at the point A comma B, we have the X A and Y B. These are the two gray levels at any point. Now, what is this? L, the small l is nothing but it is the gray level at XA comma YB. This is the function XA comma YB. The value of the function is always a gray level. And at XA comma YB, we are indicating it with this small l value. What is this small l? Small is any grayscale in the total gray level, total gray scale. And how we are indicating the total gray level? By two boundaries, L min and L max. Capital L we are using to denote the intensity, or you can say the grayscale. So L min is less than or equal to L is less than or equal to L max. That means our L at this X A comma YB, it lies in these two boundaries, minimum gray level and the maximum gray level. Okay. Again, these gray levels are the positive and the finite values. Okay, they are always positive. There is no negative gray level in this. And this interval, L min, L max, is called as a grayscale or the dynamic range of grayscale. We are shifting this interval from 0 to L minus 1 because 0, as I said, it is a grayscale. So 0 is a total black. And now what is white here? If we are using different grayscale, instead of writing 1 for white, we are now writing L minus 1. That is the highest gray level as total white, that is 1. If it is a simple black and white image, 0 is black, 1 is white. But if it is a grayscale image, the different combination. So what is the highest grayscale? It is termed as white. So L minus 1. As we are including 0, our highest grayscale is always L minus 1. So this is the interval. We call it as a grayscale. So what we have discussed is nothing but it is the simple image formation model. We have to always remember this particular equation is very important. F of x comma y is equal to I of x comma y into r of x comma y. Then we will discuss some of the basic elements in the image processing system. So whenever you want to capture the image and process it, we have to store. First capture, then store it on the computer, and then we have to process. And for that, we require a specialized image processing system with specialized hardware and specialized software. So all these things we have included. In the problem domain, we have to capture certain image. So we are using the image sensors, and we are capturing the image through the with the help of the sensors, and then using the specialized image processing hardware, we are like our imaging system or the camera, we are converting this image into the digital format because we want to store it on the computer. So what is the purpose of this? The specialized image processing hardware converts the continuous image into the digital format. Then after storing it on the computer, either you have to store it or you have to display it. So you have mass storage device to store the images, and you have a display device to display the particular devices, or you have to take a printout like hard copy. Then you have this option for it, hard copy, or if you want to transmit using this network, you can transmit it. And for all these, for processing, we require a specialized image processing software. Okay, so this is a specialized image processing software. This is very important because using this only we can do all these things, that is different type of processing. So total 7 terms in the base or 7 elements: image sensors, computer or the processor, which actually makes the processing, image processing hardware, that means we have to convert it as a binary digital images, image processing software using which we can process on the images, then image displays to display the image type of data, specialized display devices we require, and the mass storage to store, because we know that one image requires a huge amount of data or huge space to store its all data, we require the mass storage of very high quality and the hard copy or transmission to transmit or to print it. Now we will discuss some of the image types which are generally used in the image processing. Generally, in the image processing, we are using the bitmap images, which are the raster images also, and they are nothing but, as we have already discussed, it is the 2D representation function f of x comma y, and having the pixel data and the corresponding gray level value stored at some file format. So they all are called as the bitmap image. There are number of such file formats available for storing the bitmap images. But another type is there for the complex processing of the data. They are called as the vector images, and they are the methods of representing line, curves, and shape by storing only the keyword. Instead of storing full data, that means all the pixel, all the gray level, we are only storing some of the features in terms of lines, curves, and shape. And then these points are sufficient to define the shape. But whenever we want to process it, we have to use the processing called as rendering to convert this particular image again in the bitmap image, and then only we can again process it. So bitmap image is very, very important and must in our image processing. There are different image types which are used in the image processing: binary or monochrome image. Monochrome, only one single bit is there and one single color, that is the black and white. Binary, only two values, 0 or 1. Only one bit storage space it requires for per pixel, and that's why only two values of grayscale, 2 raised to k, it is only one, and that's why two values, black and white. So it is a binary image. Then the different combinations of black and white, they are the grayscale images, color images, which requires RGB images, multispectral, and index. Let's see this one by one. So as I told, it is only a typical image, digital image, with only one bit per pixel, 0, and having the two values only, 0 or 1. So 0 indicates black, 1 indicates white. And these binary images are encoded as a two-dimensional array as shown over here. So this is a binary image, only two colors, black and white. So not much details are visible in this type of image, only this background and certain boundaries you can see. You can just imagine what object can be there, and you have only two values in this two-dimensional matrix also, 0 and 1. Okay. So binary images, the only advantage is they have very small storage space required, because only one pixel is stored using one single bit. Then the combinations of black and white. Now see, more details are very clear, though it is a black and white image, but the details are very clear because we are using the combinations of black and white called as the grayscale. We have discussed it. So grayscale or the monochrome image is encoded as two-dimensional array or pixel. Till now we have discussed all the details of this. Then you have 8 bit per pixel. If then you have the grayscale 0 to 255. We have just now discussed. So 0 corresponds to black and 255. Now which is the highest grayscale? That corresponds to white, and the remaining are the combinations of this black and white. The different values are given as per the quantity of black and white present, and they are the varying shades of this gray. The third is the RGB values. This is a color value. As we have seen, one grayscale value is represented using one single plane. Similarly, for representing RGB, that is the color image, we require 3 two-dimensional arrays, one for red, one for green, and one for blue. Now see, 3 planes we require RGB, 3 different planes, and when you combine these 3 planes together, you get a colored image. So this is the highest storage. It requires the highest storage because for one pixel it requires at least 24 bits, because every plane requires 8 bits, and that's why such 3 planes are there, RGB, and that's why they require 24 bits per pixel, okay, to store the value. So the storage of this color image is always higher. And multispectral images, there are many applications where our normal color images are of no use, especially in infrared, ultraviolet, X-ray, or acoustic or the radar data, we have whatever the images that we are capturing using these techniques, they are not visible through our normal imaging system or the normalized. See, you cannot capture the X-ray using our normal camera. You require certain different imaging system for that. And because the type of the image that we are capturing is the multispectral image. Okay, and this is a normal human perceptual out of range data, and that is not directly visible to the human eye. But we have to represent this information using certain mapping on the RGB images. But the type of this multispectral camera image is something looks like this instead of this type of RGB images, because it has some different amount of data. We will not discuss this in much detail. This is just to know what is the difference between this RGB image and the multispectral camera image of the same object. And one more type is there, we call it as an indexed image. When very high amount of data we have to store, instead of storing the full pixel values, we are storing it using certain indices. So there is one index matrix and there is one color map. So these two images are index representation of 2D array, index matrix containing pointers to the color palette, and the color map, just the list of colors used in that particular image. So it is having the index value, and this is an actual color palette. So instead of representing the full color palette, we can represent it using this index, and when required, you can see the details of this. So this is one more type of the image called as the indexed image. For complex images, you can use this type of imaging. So this was regarding the image types, and now what we are going to discuss, it is the image formats. The image formats are used to store the image. What is image type? They are the types of image, whether it is black and white, color, grayscale, and so on. And what is image format? Whatever the image we have captured, how we are storing, in what format we are storing. So it based on the extension like PMP, PNG, PIF, JPEG, and so on. Let's discuss these 8 types one by one. So .bmp, it is the bitmap image file. It is ending with .bmp. This is the most common image, and it can be not only used for the monochrome images, but it can be used for the color images also. But it is a raw type of data. You have not stored, you have not compressed, you have not done any type of processing on it. Whatever the capturing device has captured it, and then you have started storing it. So it is just a, you can say, without any compression, this data is stored. So it requires a high storage space. Okay, this method is storing image information for crisp, high quality graphics, but also produces large file sizes. So .bmp, we are not using any compression technique to compress. We have to reduce the size of the data for sake of storage, and that's why we are not using any compression over here. Whatever the data you got, you have stored it as it is. But you can use it independent of the type of hardware. You can use it anywhere because you have not applied any type of processing on that particular data. So it is a very simple and very basic format. Then there is a PNG, portable network graphics. It is created an open format to replace GIF that we are going to discuss afterwards for animations. But it allows a full range of color and better compression of type lossless. We will see it in the compression, 2 types of compression, lossy and lossless. And as the name lossless suggests, it did not loses any amount of data at the time of compression. That's why it is called as a lossless compression. Very good quality of compression technique it is. So PNG is that quality. Now we have 2 different file formats. JPEG now we are going to see, which are very favorite file formats. So PNG is also very favorite file format, but it is a heavy weight. That means the amount of data stored over here is more as compared to JPEG, so you are making a lossless compression. So it is a compressed format where the size is reduced, but the quality is not as good as the JPEG that we will be going to see afterwards. But still it has the advantage that it gives you the high quality files It supports the transfer patterns. And the disadvantage, it is heavyweight. That means it makes the processes slower to load or to store like that. But whenever we are using the logos or websites, it is always better you are using the PNG file formats. It gives the good results there. The next is the TIF, that is a tagged image file format. TIF image creates very large file sizes because it is an uncompressed format and contains the lots of detail of the image. Whatever you have captured, again the same as it is TIFF. It is, but the main advantage, it is extremely flexible in terms of color. That means it can be grayscale, it can be CMYK format, it can be RGB or anything where you, depending on your application, you can use it. And that's why this is a very flexible file format, though it is an uncompressed type of data. And it is very common, and in the softwares like Photoshop, they prefer to use this kind of file formats because they can make many processing on the uncompressed data, because you are getting most of the details available as it is uncompressed. And that's why they are using this type of softwares. They are preferring this TIFF type of file formats. And then JPEG. On the social media, this is very popular format. Most of the files that we are using, they are in this particular format. This is again a compressed file format. You will take a less space to store, as well as you have to transfer a less amount of data, and that's why this is very popular. But this is a lossy compression. You are losing some of the details, and that's why the data which is very important, where you cannot afford any loss of data, you cannot use the JPEG. So it loses the quality, and when it is saved multiple times, is go on compressing it, and that's why it loses the quality. But the advantage for our normal social media files, it is a lightweight file, viewable, and any program can download and view it. And that's why most of the cameras and on the web, it supports this JPEG file format. So most of the time, web design, social networks, portfolios, we are using this compressed file format JPEG. Then GIF, as now on the social media nowadays, we are exchanging many GIF, that is GIFs. So here, whenever you have to make short animations, so instead of using the JPEG, which is a compression, it is a different form of JPEG, but it supports the animation, and that's why we can use this GIF file format. The format compresses image, but as different from JPEG, the compression is lossless. We have seen the JPEG compression is lossy, but GIF compression is a lossless compression, and that's why it is very popularly used on the social channels for short animation. But the quality, that means while displaying the gradient color, is poor. That is the disadvantage. Then the PDF, all of you know that when you send a PDF file on any of the device or on any of the hardware, it doesn't change the formatting, and that's why it is very popular. Most of the document and most of the files we are sending, they are in the PDF file format. So file format is used on the online documents and printing purpose. It is created. The only thing is that we require a specialized reader for this, a PDF reader. So Adobe Acrobat, like this type of reader we require to send the words or documents or the images. And anywhere online, you can send the documents and the images, that is printable material, using this PDF file format. It is again, you are compressing the data. That's why your size of file also gets reduced, and similarly you can send the data very effectively. The next is the mpeg, moving picture expert group, like JPEG. It is the JPEG file format we are using for files. Similarly, mpeg file format we are normally using for the videos and audios. So most of your videos, they are MP4 files. MP4, it is the multimedia container format. Okay, so it can be audio, it can be video, and again it is a compressed format, and that's why it requires a less amount of space as in the JPEG. Again, it is a lossy compression, but it is used for the videos and audios specifically. It is the lightweight as like JPEG, playable on all major media players, and streamable online. Disadvantage is only you have to search high and low, but it seems that the file type has no flaws. That means it shows it is flawless, but it cannot search this high and low values. And the best places to use it on the website or the social media to send the videos and audios like songs or pictures and so on. Now this is the basic data. Whenever you capture any image and you have not stored it in any of the discussed file formats, it is the raw image. So raw image file contains the data directly from the digital camera without any processing, without any compression and anything. These files are called raw because they have not processed, therefore they cannot be edited and printed. What you understood from this? Whenever you have to feed the data on the computer, you have to make it converted into the digital format. If they are not converted into the digital format, no computer can read them, and they are the raw image files. Though your camera has captured it, but if it is not converted in the machine readable form, they all are called as the raw image files. But still, there are many raw data formats that camera companies, they have their own formats. While capturing it, there is an internal storage in this format, and it is a proprietary data. But when you want to store it on the computer, definitely you have to use whatever the options we have previously discussed, like GIF, JPEG, MPEG, and so on. Then you have to convert it into the TIFF before editing or the color correcting. And the size, as this raw data is not processed, so no processing at all. That means no compression also, and that's why the size of the data is too high. So first you have to convert it at least in the TIFF, which is a very basic format, and then only you can make certain editing and correcting. So till now we have discussed the many basic, like how we are acquiring the images, how we are storing it using a two-dimensional arrays. We are generating the digital image using two techniques, that is the sampling and condensation. Then we have seen the two resolution, which are very important. Spatial, related to the space or the area, x, y coordinates, and the gray level resolution related to the gray levels or the number of gray levels that you want to use. We have seen the effect of this resolution on the image, how decreasing the spatial or grayscale resolution degrades the quality of the image. That also we have seen. Then we have seen the simple image formation model. F of xy is equal to I x comma y into R x comma y, and we have seen the explanation of that. Then we have seen the basic elements of image processing system and image types: binary or monochrome, grayscale image, color image, multispectral image, indexed image, and the different file formats, starting from raw image files directly captured by the cameras, and then they have converted as BMP, PNG, TIF, JPEG, GIF, PDF, MP4, and many more, which we have not discussed here also, but these are the important which are used in the image processing. So here we have discussed all these basics of the image processing. Thank you.